All right, guys. In this video, we're going to talk about logarithmic functions. This is section 3.4. And we are going to just first of all talk about what a logarithm is. The whole purpose of a logarithm is the fact that it is the inverse of an exponential. So that's kind of what the point is, because finding the inverse of an exponential function is pretty tricky. Without it. So what we do is we use a logarithm to help us with that part. And what you're seeing on your screen is you're seeing a exponential function. Remember that we have studied those back in chapter 3, or at the beginning of chapter 3, and we spent quite some time on that. This is an exponential growth, but it doesn't really matter. Regardless, exponentials and logarithms are inverses. So if I wanted to show the inverse of this guy, you got to think about it being reflected across this line, y equals x. So it appears like this. That's your logarithm, and that is the inverse of your exponential. Really, really, really important feature about what you are seeing on your screen also is not just the graphs, but you also need to make sure that you are checking out how you convert between log and exponential form. So if something is in logarithmic form or exponential form, we are able to actually kind of translate between the two by using this pattern that you're seeing on your screen right there. So what's important is you want to look at the base of your exponential and the base of your logarithm, right? If I read this log out loud, this says log base b of x. Okay, well, as an exponential, the base of that logarithm, that's the base of this exponential. Okay, another important feature, logarithms really are calculating that exponent, so of that exponential. So when we think of this, the log is equal to the exponent of your exponential. You also are taking logarithm of something, log base b of x. X is what goes on the other side. So what we're going to practice for a moment is, number one, just kind of untangling those parts, being able to kind of rearrange things from logarithmic form to exponential form. And then we're going to also use that to solve and evaluate certain things, what you see on that screen. So anyways, you see that first one, part A, it says log base 2 of 8. That's what we're going to start out with, log base 2 of 8. And what I want to do here is we're going to practice solving these maybe a little bit different than how you did in Algebra 2. I'm not sure how your teacher explained it to you, but I'm going to try to break this apart as much as I possibly can so that we can understand the structure of that logarithm a little bit more, and so these don't seem as scary, okay? But in doing this, it's going to take more steps. I will show you some shortcuts in a few moments, okay? So we're going to first start by just solving these the longest drawn out way I possibly can. All right, so we've got here log base 2 of 8. And what I'm going to do is, since I'm trying to figure out what this is equal to, that's my unknown. I'm just going to let that be equal. Let's just say to y, okay? And then follow the pattern that you see between converting between logarithmic and exponential form, okay? So if I do that, I would be taking the base of my log to be the base of my exponential. So let's turn this into an exponential equation. The base of the log was 2. That's going to be the base of it as an exponential. Remember that how a log is equal to the exponent here? Well, my log is equal to y, which is my exponent. And that's going to be equal to 8. So let's kind of break this down, right? We want to solve this out. How do we know 2 to what power is 8? Right? That's what we're trying to find. Well, let's think about it. 2 raised to the third power is 8. So that means that value I was looking for is 3. If 2 to the y equals 2 to the third, y is 3. And so I'm going to write that a little bit nicer here, because really what we were looking for is to evaluate log base 2 of 8, and that answer was 3. Okay? Let's try another one. Again, I'm going to keep drawing these out a little bit, make them a little bit more longhand, and then we will do some shortcuts on example 2, okay? So here we're going to do the same thing. I'm going to rewrite this here. But I'm going to set this equal. Remember, we're trying to solve for that logarithm, but I'm just going to let that be a variable for right now. That way we can manipulate this a little easier. And I'm going to convert this into exponential form. So the base of my log is the base of the exponential. The log's equal to the exponent, y. And then that's log of the square root of 3. That's going to go here on the other side of the exponential. So it's a lot of untangling and trying to figure out where these go, what pattern this matches. Okay, so now I need to think about here. 3 to the y equals 3 to the what? The square root of 3 as 3 raised to a power. Well, got to remember that this little 3 under the radical has a little invisible 1 on it, and the radical has a little invisible 2 as the index. So if I write this as a exponent instead, we take the 1 over the 2. This is 3 to the 1/2 power, meaning my answer was 1/2. Log base 3 of the square root of 3 equals 1/2. Yeah? We're going to start getting into some interesting properties over here. Look at this guy. We got log base 4 of 1. We're going to do the same thing and set it equal to y, and we're going to put this in exponential form. Follow that same pattern. The base of the log is the base of the exponential. The log was equal to the exponent y, and that's equal to 1. So now we're going to solve this, and you got to ask yourself, 4 to what power was 1? Well, that's 4 to the 0 power, because anything to the 0 power is 1. That means that my answer was 0. Log base 4 of 1 equals 0. And guys, that's a very nice property, because anytime you do log of 1, no matter what the base was, if it's log of 1, your answer is 0 because of that same reason. Okay? One more of these, and then I will give you your shortcuts, okay? So log base 7 of 7. This is a nice little property too. These little values match. I'm going to rewrite this guy, log base 7 of 7, and we're going to say equals y. Go through and solve this the same way we did a moment ago. So I'm going to take the base of my log, which is 7. We're going to raise that to the y power equals 7. Well, this is a 7 to the first, right? It's just unwritten. So really, y is 1 here, meaning log base 7 of 7 is 1. That's another nice little property, guys. You notice how the 7s match here? If these numbers match, no matter what they are, the output is 1 every single time. Okay? So that's bringing me to my properties. Then a couple more fun examples. So go ahead and get those copied down, and then start the video back when you are ready to go through the examples below. We're going to do example 2, and what you'll notice about A and B is A and B are the exact same A and B from example 1. The difference is we're going to work them using properties, which allows us to do them with less steps. So that's what we're going to do. Okay? All right. So example 2, we have this log base 2 of 8, right? And we're going to use the properties that you see above. Now, let's make sure these properties kind of make sense. This says log base b of 1. If you refer back to the question C we did right before this one, that was a very good example of this. Anytime you do a logarithm of 1, your answer is 0. Okay. What about the second one, log base b of b? Hey, that is like what we did on part D of the example before. Anytime these two numbers match, your output is 1. Okay, then things get a little bit more interesting. What if it was log base b of b to the y? Well, your answer is just y. These guys end up canceling each other out and leaving you with y. And then we get this one down here. Now, this might have been hard to read. My hand did not want to write very neatly here. But this is b raised to the log base b of x power. Guys, if these numbers match once more, then this stuff basically just cancels out and you're left with that x, okay? So we're going to use some of these properties. We may not use them all right here, but that's okay. I'm going to start off with this first problem. And although it is the exact same problem I gave you in example 1, I'm going to show you a different way to work it. Rather than making it to where I have to switch to the exponential form, let's use a shortcut. I am going to have to rewrite this, though, a little bit. This is log base 2, and instead of writing an 8, I want to write this number so that it matches the base of my log. Log base 2 of 2, but I need to make sure this value is the same as it was before. 8 is the same thing as 2 to the third power. And so I'm allowed to write it like this: log base 2 of 8, log base 2 of 2 to the third. 2 to the third is still 8. But that allows me to use the property you're seeing up here as the third one. Log base b of b to the y, the answer was y. Log base 2 of 2 to the third, my answer is 3. So you get the same thing we got on example 1, part A, but a different way to do it. Look at this one. We're going to do the same thing. I'm going to rewrite this so that I am doing log base 3 of 3 to whatever power. Just like above, when you have the square root of something, that is the same as the 1/2 power. And once you have these values match, then you're able to say your answer is just that exponent. And guys, we get to this last one, and this last one is the easiest of them all. It is this last property where you have b raised to the log base b of x, but I want you to look here. This is 6 log base 6 of 11. You see how these two numbers match? Because those two numbers match, my answer is just that 11. You don't have to do any work, actually, in some cases. Real nice. Okay. What I'm going to have you guys do is I'm going to have you pause here, and we're going to have split this into 2 videos. So definitely make sure that you stick around for the next video, because we are not done with logarithms, but I think this would be a good breaking point. So pick up again where we left off if you need to watch the other video, okay? I'll see y'all in the next one. Bye.